Hi, my name is Dan Cavise.
My name is John McNeilis.
I'm Alex Nicaza.
And I'm Bianca Pellicino.
Some of the goals for this project included properly coding and designing a propeller-driven vehicle that is required to stop at certain points and pick up a caboose.
Another goal of this project was to optimize the efficiency of the AEV that he mentioned. In order to do this, the engineers used the engineering design process cycle.
It was important to properly manage the project with teamwork.
The team kept up with documentation by keeping a project notebook throughout the AEV process.
The team created their designs trying to make them as aerodynamic and light as possible. The team used concept screening and scoring tables to evaluate each team member's design.
After doing this, the team decided to combine Alex and Dan's design, which was their initial design concept.
The engineers tested two different AEV designs with the same code to determine which one was the most energy efficient, proving Alex and Dan's design to be the best fit. The final design was created to be stable by having the Arduino and battery centered in the middle and durable because it had very few parts. This design was the lightest, most energy efficient, and most cost-friendly out of the four initial designs that each team member created. The AEV was able to carry out the requirements in the MCR by being able to stop at the required gates and pick up a caboose and go back to the starting line.
We faced a few different obstacles during this project, one of them being the propellers. After running the propellers so many times on the same motor, the propellers became loose and therefore did not rotate as much as they needed to for how much power we were giving to the motor. Therefore, we needed to replace them with new propellers.
The other challenge that the engineers faced was the strength of the battery on the AEV. Throughout the course of a class period, the battery strength on the AEV would decrease. This would in turn alter the AEV's behavior and alter its consistency every time you ran the code.
We had a problem between the two tracks in rooms 308 and 224, with the track in room 308 being slightly different, just enough so we had to make a new code. The other problem was using the yellow caboose in room 224. We found that the magnet on the caboose was not as powerful and would end up disconnecting with the AEV during the trip home. For this reason, we determined that we need to use the green caboose during every trial.
The last obstacle we faced was trying to get all the required tasks while also trying to maximize its efficiency.
There's a few different things that the group of engineers learned during this project, one of them being the design process cycle. We ultimately learned that through the use of less materials, it overall made our AEV more efficient because it weighed less.
Another skill that the engineers learned when completing this project was how to troubleshoot. Each time, we all expected the AEV to perform the same way when running across the track. However, we quickly learned that this was not the case. We learned how to troubleshoot and how to manage our issues and make the best of what we had.
It was also very important to learn how to troubleshoot problems with the code, especially traveling certain distances at different powers and how it affected the AEV. Stopping at the gates was a big problem, and not passing the second sensor. Also adjusting the power of the code during the trip back, since there was a greater weight being pulled, as it was the weight of the AEV and the caboose.
The team learned to work effectively as a group by assigning roles and tasks to each individual.